Okay, before we get to generating functions, we have one more example of doing a binomial expansion with a negative exponent. And this example now comes from physics. And here what we have written is the kinetic energy of a particle, or we should say its relativistic kinetic energy of a particle. It is this times the resting mass of the particle multiplied by the speed of light squared. And what we're going to do is get an approximation for this formula by using the binomial expansion when we have a negative coefficient. First, let's just rewrite this part of it. We can say that the kinetic energy equals 1 minus v squared over c squared to the negative 1/2. That replaces this part. Then we have minus 1 times its resting mass multiplied by the speed of light squared. So here we can use the binomial coefficient with negative exponents to replace this part of the equation. And remember from our last video that we posted that 1 minus x to the negative n has a very simple expression. We start with this binomial coefficient, and then we continue adding 1. The bottom part stays the same, and the exponent on x continues to increase with each successive term. This is a minus sign, so all the terms are positive, and it is an infinite series. So it continues on like this to infinity. We'll get an approximation for this by considering the first 3 terms here, and technically the first 4 terms in the series, counting this one too. So here we have then that 1 minus x is going to be v squared over c squared to the minus n equals plus 1/2. So this of course is just 1 plus, and here we'll just say n over n minus 1 times x, which will be v squared over c squared. Try to keep it in better focus as we work along here. And let's see, the next term will be plus n plus 1 over n minus 1 times x squared, so that will be b to the 4th divided by c to the 4th plus n plus 2 over n minus 1 times x cubed. That will be v to the 6th divided by c to the 6th. And remember, n equals 1/2. Before we plug the n in, let's go ahead and work with these 3 binomial coefficients. So right now we have this is equal to 1 plus, this would be n factorial over this minus this, n minus n minus 1 would just be 1 factorial times n minus 1 factorial, and this is times v squared divided by c squared, and the next term is plus, here we have n plus 1 factorial divided by, now we have this minus this, so we're going to have 1 minus negative 1, or that would be 2 factorial, times just this, n minus 1 factorial, and that is times, this should be to the 4th power down here, times v to the 4th divided by c to the 4th, plus, from this term here, we have n plus 2 factorial, and then we have this term minus this term, that will be 3 factorial, times n minus 1 factorial, from that binomial coefficient, and that is the term for v6 divided by c6 to the 6th power. Now we plug in, well, let's just do one more step here before we plug in values. So here, this equals 1 plus, now here we have n factorial divided by n minus 1 factorial, so on top we will have n times n minus 1 factorial divided by n minus 1 factorial times v squared divided by c squared plus, here we have n plus 1 factorial, so we will have n plus 1 times n minus 1 factorial divided by 2 factorial times n minus 1 factorial times v to the 4th divided by c to the 4th. And for this term, let's write it down here, we have plus n plus 2 times n plus 1 times n minus 1 factorial divided by 3 factorial times n minus 1 factorial times v to the 6 divided by c to the 6. So we see what's happening here. These cancel. These will cancel. Let's just get rid of them. These will cancel. And there's the expression that we have to work with. Remember, n equals 1/2. So here we have 1 plus 1/2 times v squared over c squared. Let's just make some room. 1/2 times v squared over c squared. And here we have n times n plus 1. 2 factorial is just 2. Get rid of this. So here we have 1/2 times 3/2. That's 3/4 divided by 1/2 makes this term 3/8. So let's make some room. Plus 3/8 times v to the 4th divided by c to the 4th. Now here, 3 factorial, this is 6. And 1/2 times 3/2 times 5/2. That is 15 over 6 divided by 6, or excuse me, that's 15 over 8 divided by 6. That would be 15 divided by 48. And let's see, this is 3 times 5. This is 3 times 16. So our last term is 5/16. So we have plus 5 over 16 times v to the 6th divided by c to the 6th. So let's just make some room. Here we have that this is equal to this expression. In these other terms, we're just getting an approximation by taking the first 3 terms. Remember that since this is a negative exponent, if there's an infinite number of terms here, typically what people will do is they'll take the first 3 or 4 terms to get a reasonable approximation. Now notice, so we're going to put this into here, and when we do that, we're going to have 1 minus, oops, we don't have enough room here. Okay, this will substitute for this, so this 1 will cancel out this 1, and what we will have then for our final expression, that the relativistic kinetic energy is equal to the resting mass times the speed of light squared times 1/2 v squared over c squared plus 3/8 v to the 4th divided by c to the 4th plus 5/16 v to the 6th divided by c to the 6th. And there's our answer. So, as you can see, it's a pretty straightforward task. Once we become familiar in how to work with binomial expansions with negative exponents. And again, in our next video series now, when we start dealing with generating functions, we'll have a lot more experience in doing this. So you just want to take 5 or 6 videos and try to lay out the background. But anyway, that's it for this video. Come back and join us for the next videos, and then we're going to start getting into generating functions and explore how we can use those as very powerful tools to solve some of the more complicated combination and permutation problems. So come back and join us for those videos.